All right, let's take a look at our divergent boundary features. We've got two maps that we're checking out here with all the features we did for convergent plate boundary. First thing on our table is, of course, looking at the types of crust. And remember, the crust is representing what's happening with the Earth on either side of the plate boundary. So here is our boundary we focused on in map A. So the crust is looking at what's on either side of that particular crack, essentially. I did get a lot of people saying, well, here's the land, so this side must be continent. But we do need to keep an eye on what's happening at the boundary. We don't have any of this land right on the boundary line. So this is looking at oceanic and oceanic crust. On this side, we have, again, the boundary. We see both land and water on the map. However, on either side of the boundary, this one we're looking at two pieces of continental crust. So we have ocean for map A and continent for map C. So you should be looking at your part 2 divergent table and go ahead and make a note that we're looking at ocean crust, and continent crust. And this is again for a divergent boundary where the plates are moving apart. So we're going to start here by looking at earthquakes happening at both locations, and then we'll roll on to all the other features. So before we take a look at divergent, we do have to just recap convergent quickly. These are, of course, our boundaries, the red lines running through the map, and we can see quite a few earthquake dots on here in varied depths, right? We saw them in every single depth on most of these boundaries. We also noticed that these earthquakes were both on and off the boundary line, right? We see them both touching the boundary and away from it, and again, a considerable amount off the boundary, and they were really non-symmetrical. Right? We really focused on them being on one side. Here they're on the island side, here they were on the continent side. So that's what we were looking at for convergent. When we look at the earthquakes here at the divergent map, it's really a lot less. I barely see any of these dots compared to what we just saw on convergent. So the first thing we are going to make a note of is that this is fewer than convergent boundaries. They're still there, but just quite a bit less. So we're putting this information again right here in our earthquake chart, map A, earthquakes. So we have fewer than convergent. We can see there's a smattering of them happening right on the boundary line. That's where a majority of them are showing up. And in terms of depth, we're seeing them all in that red category, which of course is shallow. So that's our divergent A details right here. Let's go ahead and move on to map B, earthquakes. We do see a few more happening at this location, but we do see quite a few of them happening on the boundary. So we are going to make a note. Most are on the boundary, but we do have a few occasional ones off and scattered around. In terms of depth, again, red is the main color, telling us the earthquakes here are shallow. So we do have some similarities between these two locations. Topography, remember, is looking at the elevation, both above sea level and below. So we have this scale of all the greens, yellows, and whites for land, and all the light blues, dark blues, and pinks for ocean depth. In the questions, I asked you really carefully to look at what's going on the boundary line. And a lot of you did notice that it was a little bit lighter color there at the boundary. So it's the shallowest ocean on the boundary line. So what we have is a higher elevation or shallower sea on the boundary. And while we move away from the boundary, we're consistently seeing that darker blue color, and it's all over the place. So away from the boundary, it gets deeper. Not the deepest, that's the pink. We don't see that here, but just deep. So we have what's happening both on and away from the boundary. And when we think about symmetry, or if the boundary is the same on both sides, it should be a quick yes. We do see the same patterns and visuals happening on the left side as we do on the right. You know, the land is a little bit different, but that immediate area where we're looking at topography, that is the same. So we do see symmetry here. Symmetrical. For map B, again, here's our boundary running right through the Earth's continental crust. This one is running on that same key. We're now just looking at the above land colors. So we have green, lower elevation, yellow, medium, and white, higher. We do see quite a bit of this yellowish brown across the map, and this one has better visuals. So I was hoping that you would notice it looks kind of wrinkly or rocky here. Those, of course, are our mountain ranges, and those are happening on either side of the boundary line. So on and around the boundary, we have the highest elevations. As we work our way away from the boundary, we're seeing that yellow change into the green color, reminding us it's becoming a lower elevation. So in map A, we said moving away is deeper. Instead of deeper, we're saying lower because we're still on land. And because that's happening on both sides of the boundary, we can use again that word symmetrical. Age of the seafloor, this was something that only applied to map A, as map B was looking at two pieces of continental crust, so there was no seafloor data happening here. Looking at the boundary line, you should see one prominent color surrounding the boundary, and that is the red here, representing the youngest oceanic crust. So when we put our data in for age of seafloor, we should recognize that we see the youngest rock at the boundary, right? That boundary line is surrounded by the red. And as we work our way away from the boundary, we're seeing that crust become older and older. Old, away from the boundary. Now in terms of symmetry, on both sides we're going from that red, yellow to green, and in some places ending in blue. And so it's doing that same getting older pattern in every location we can see. So again, symmetrical is a great describing word. Our final map is looking at volcanoes. We can see again our plate boundary running right down the middle, and at first look there's not a whole lot there, but we do see a few scattered around. Again, we have less than convergent, but we really don't have enough to designate a constant theme. So we're just going to simply say a few on and a few off. Again, no particular patterns, but in our divergent continent here, we're looking at our boundary, and we can see a consistent amount of the volcanoes showing up right on the boundary. So that's what we want to notice here. Many on boundary. There's just not enough off the boundary to start looking at symmetry. All we're really seeing is on at this point. So the two locations we were investigating is one here, something called a mid-ocean ridge, where we have this feature running, you guessed it, down the middle of the ocean, where the two plates are moving apart. And we were seeing that same thing happen here on land, where the two plates were separating and we're creating this valley where they're being pulled apart. So you should have your entire table completed. If you need to go back and pause at any of those points, feel free. You have just a few summary questions left, and then go ahead and get that submitted. All of this is guiding you for your first tectonic homework check. So make sure you have everything completed, fire that up, think carefully, and as always, message me your questions.